Hi guys, so for today's lesson we're going to be dealing with normally distributed data. This is a new topic called the normal distribution. So firstly, let's start off, what does these words normally distributed data mean? Well, we're talking about a data set. So remember, a data set is just like a list of numbers like we've got here. This data set has roughly an equal mean, median and mode. So it's really important to understand that there's special properties about this data set, where the mean of this data would be the same as the median, would be the same as the mode. So for example, here we've got a normal data set, and the reason is because if we figure out what our mean is, if we add these numbers up and divide by the number of data entries we've got, we'll get a mean of 3. The median, the middle number, in this case is going to be a 3 as well. And also the mode, the most common number, is also going to be our 3. So here we've got that the mean, the median, the mode are all equal. So this is 100% a normal data set. It's pretty much perfect. Next up is a normal or a bell curve. It's the name given to the shape of the histogram when we graph this normal data set. So this is our normal data set as an example. Let's graph it on a histogram. So when we're making a histogram, guys, you need something like this. When we're graphing it, we think to ourselves, well, how many, firstly, we've got 1, 2. So for the 2, we go up to 1 because we've only got one of them. Notice that we don't have any 1s, so I'm not going to even worry about the 1s. We've got 2 3s. So for 3, we go all the way up to 2. Sorry about the messiness. So there's for our 3s. And then we've got 1 4. So we go for 4, we go all the way up to 1. And here is our histogram. Now, we're concerned about a normal or a bell curve. I don't see any curve here, but what we can do is we can pretty much go from the top of each of these columns, and you've got to remember to do the ones which don't have any, so 1 and 5. And then from these points, I'm going to literally make a nice smooth curve from the tips of each one. And what you'll see in red is what we call our bell curve. The reason why it's called a bell curve is because it looks like a bell. Looks like a bell. So if you can kind of visualize, if I go along the bottom there, you kind of get this sort of bell shape, if that makes sense. And that's really important. It has to look like a bell. That's why we call it a bell curve. Okay, so another thing to notice is that this data, or this bell curve that you see, is symmetrical. And it's symmetrical, its line of symmetry is where the mean is, where this average is. So there's my line of symmetry. It's kind of halving the bell shape, and it's going to cut through this mean of ours, this mode, or this median or a mode, which of 3. So really important property there. Okay, here's an example of a larger bell curve. So we can see here is in the middle is like our line of symmetry roughly there. But you'll notice that the bell curve doesn't quite match up with the tips of all these columns. And the reason is because it's not always going to be perfect, these bell curves, but it's roughly making that sort of shape. You can kind of look at these columns here, and they're roughly making that sort of bell curve shape. Like you can see that it drops off to the left and right, and a majority of the data is in the middle. These are the sorts of things that give away that it's a normal normally distributed, that it's a normal distribution. So it doesn't have to be perfect, but it has to roughly make that sort of shape. So this still counts as a bell curve and a normal distribution of data. Okay, so some rules to remember. Normally distributed data that makes these bell curves, are described by their mean and their standard deviation. So these two things here, mean and standard deviation, are really important to describing these sets of data. So let's have a look at this set of data that's already been graphed for you. We can see that the mean is roughly 40, and the reason is because kind of the tip or the axis of symmetry lines up roughly with 40. The 40 is kind of in the center. And the standard deviation is low. We don't care about exactly what the standard deviation is, but we know that it's relatively low. And the reason is because the data values are close together. You'll notice that we've got lots of data in between 30 and 40, heaps around the 40 mark, and a bit under 50. So they're all clumped together in this sort of 30 to 50 region. So that suggests that all the numbers are close together, and that suggests that the values don't deviate much. The standard deviation is low. The next sort of bell curve that we've got here is this sort of data set. So this is where we've still got a mean of 40. We can see that kind of the peak is around the 40 mark. Our axis of symmetry is around here. But the standard deviation is higher. And that's because we can see that there's lots of data entries around the 15 to 30 mark or around the 50 to 70 mark. It's the data entry spread out around 40 a lot more compared to this data set. So this suggests that the standard deviation is higher. We don't know how high, but we know that it's a lot higher than this one. Okay, so moving on, an example question. So consider the following data represented in a stem and leaf plot. So there's our stem and leaf plot on the heights of 12 rugby players. So we've got data from a rugby team and we've asked them what their heights are, and they've given us this sort of data set. Okay, so with our data set here, we've got to show, is this data normally distributed? Okay, so strategy. So when we're figuring out whether a data set like this is normally distributed, we need to firstly show that the mean and the median are roughly equal. It's a really important idea for normally distributed data. Show that the mean and the median are about the same. So what you would need to do with this data set is to show that figure out the mean, figure out the median, and see how close they are. So if I figure out the mean of this data set, I'm pretty much adding up all these data entries together. So here we've got 42, there we've got 45, here we've got 53. So we're adding up all those values and then dividing by how many we've got. So we've got 12. And we get a mean of 63.93. If I find the median of this data set, it comes out as, I think these two were the middle numbers there. So our median was 64. In between those two, and they're roughly equal. They're not perfect, but they're roughly the same, and that's all we need. So that's kind of satisfying the fact that we're showing that the mean and median are roughly the same, and that's a really important property of normally distributed data. Okay, so step 2, we want to show that the data is roughly symmetrical. So that suggests that when we make this bell curve, we can see that the data, the property of a bell curve is that these bells are roughly symmetrical. So there would be our line of symmetry like that. It's a bell curve on its side. So we can see here that we've made this bell curve. We've kind of wrapped around the tops of our stem and leaf plot, and it's making this desired shape. We want to see a bell shape. That suggests that it's normally distributed. So we can see this sort of symmetrical shape happening with our data. So that also suggests that it's normally distributed. Step 3, we want to show that a majority of the data is around the mean. So our mean was 64 or 63.93. Sorry, our mean was roughly 64. So 64 is kind of in the 60s. And we can see that a majority of the data is around this 60 section. We can see that the peak sort of happens here. So it's really important to show that the peak of the data, or the majority of data, is around the middle of our data set. And that is the case. We see a majority of data here. We've got 5 numbers in the 60s. So that's another property of normally distributed data. So conclusion, all indicators suggest that this data is normally distributed. So whenever you're dealing with a data set and you have to show whether it's normally distributed, come back to these steps, see if these are the case. And if they are, then it does suggest that your data is normally distributed. Good luck with the questions.